Good afternoon, everyone, and perhaps good morning if anyone's tuning in from Hawaii. Welcome to the webinar today from the NASIO-NARUC Grid Interactive Efficient Buildings Working Group. I do want to give it another minute or so because I see that there are attendees still dialing in, so please hold on for another minute if you can. Okay, again, welcome to the webinar. My name's Rodney Sobin. I'm a Senior Program Director at NASIO. Glad to welcome you to today's webinar on from the Grid Interactive Efficient Buildings Working Group, which we and our colleagues at NARUC sponsor to support information exchange and knowledge and information on grid interactive efficient buildings and demand flexibility. We're very privileged today to have a couple of speakers. Casey Radcliffe from the Oregon Department of Energy will be providing some introduction, and we'll discuss a bit about the working group. And Tim Treadwell of the Portland General Electric. Before we get on to Casey and Tim, next slide, Ed, please. Do want to mention a little bit about logistics. All attendees are in muted mode so that we don't get background noise. If you wish, please do ask questions using the question box, which should be on the right side of your panel. You can also raise your hand to be recognized and unmuted, but generally we prefer the question box just to avoid the possibility of noise. Generally, we've been recording the webinars and slides. There is a little bit of a revamp of the NASIO website, so there may be a delay. If you do want the recording and the slides before we officially post them, please send an email to either me or to Ed Carley. Our information, I think, was on the registration site in which you registered for this. And with that, I will, next slide, please. I will hand it to Casey, who is one of our two co-chairs of the NASIO-NARUC Grid Interactive Efficient Buildings Working Group. So Casey, take it away, please.
Hi, everyone. Thanks for joining us today. And thanks to NASIO-NARUC for organizing the webinar. So we wanted to share a little bit about grid interactive buildings. You may have seen some of this on our previous webinars or presentations or materials. I'll start with what is a grid interactive efficient building, and we have been lovingly calling them GEBs, and our colleagues over at USDOE gave us some characteristics that help understand that these buildings are efficient, connected, smart, and flexible. And so some of the opportunities we see with grid interactive efficient buildings is that the advancements in this technology, platforms, the building sciences, and partnership with utilities and data have a large opportunity to reduce costs, enhance resiliency. It has environmental and climate benefits, including emissions reductions, and utility side benefits, along with peak reduction, ramping, improvement in grid services, and then the design of those buildings being efficient to start, that not only leverages and enhances energy efficiency, but allows some opportunities to do some demand side management, DR, and renewable integration. So our working group has been focusing on some questions about, now that we have the buildings and these platforms evolving, where can we optimize these interactions to have grid responsive buildings and take advantage of these technologies? And our part of this NASIO and NARUC partnership is how can state energy offices, utility commissions, and utility partners work together on policies, programs, and regulations to enhance and improve GEB implementation in this space. So the working group has been together for, I think, over a year. And we have support from USDOE, our state energy offices, utility partners, and now the National Lab, which is offering some technical assistance for states who are interested in certain components of assessment and implementation of GEB. So we'll go over to the next slide. And I just want to highlight some of the NASIO and NARUC working group resources. I think there's a really impressive array of resources that have been posted on the website that Rodney mentioned, and the link is in these slides. So we now have, I think we're up to 14 states with, I believe, Georgia most recently joining. So please, if you're interested in joining the working group, contact Rodney for that. And these resources really cover a wide range of some 101s, basic technology and policy discussions. It actually has a highlight of state interviews where we learned about state interest, and some information in residential, commercial applications, building technologies, end use, data portals. So I think this is a really great wealth of information and would highly recommend visiting that site. And turning to today's presentation, we heard from states when we did our initial interviews that they wanted to learn a lot from other state experience and activities and how GEB can help meet broader objectives, and how building types, assessment of performance, and the evolution of what we saw as traditional energy efficiency programs can evolve and be advanced using grid interactive building technologies and policies. So we're really lucky and thankful today to have Portland General Electric presenting on the Smart Grid Testbed Program, which is a multi-year effort. And I think this is really unique because there's a strong focus on the customer and the customer experience, along with the support and strong implementation of demand response and load management. So our speaker today is Tim Treadwell. And Tim is the Smart Grid Testbed Program Manager at PGE. Before PGE, Tim was the Director of Engineering, Research, and Analysis at the Center for Sustainable Energy and Director of Energy Technologies at ACOVA Engie Insights. So over more than 13 years in designing and launching programs and market transformation activities, Tim has a focus in energy efficiency, load management, distributed renewables, and assets, and has a background with a Bachelor's of Science in Natural Resources and a Master's in Environmental Policy. So bringing a wealth of knowledge, and is going to share with us today about the test bed. So with that, I'm going to turn it over to Tim.
Hey Casey, thanks for the introduction. Ed, if you guys can give me control, I'll bring my slides up.
Stand by. Should be transferring to you. There we go. We can see your screen.
Great. And just a quick update for everyone on situational week here. I am working from home, so there may be a dog barking. I apologize for that. And if you're not aware, Oregon is facing a lot of the same issues that California is right now, with heavy winds and wildfires, and we've had some spotty outages in and around our service territory. So I don't think there'll be an issue, but just wanted to give people a heads up on that in case I were to drop unexpectedly. So thanks for having me today. I'm here to talk about the Smart Grid Testbed, and given the audience, I'm doing a slightly different presentation than I normally do, to talk a little bit about the background and our work with the State Energy Office and the Commission, talking a little bit more about the context for the testbed and why we're doing it and how it came about, and then also get into some of the technology and the elements of the program. So really quickly, for those of you who don't know, Portland General Electric, PGE as opposed to PG&E, we're located in Northern Oregon, from the Washington border down to Salem. It's about a 4,000 square mile service territory. We have about 850,000 customers that we serve, almost half of the population of Oregon. And we're a vertically integrated utility, so own generation, transmission, distribution, and serve our customers. So this overview of what the test bed is, just with some key statistics and summary of the work. So test bed it's really a field research project. We're trying to understand how DR markets are functioning, how customers perceive and understand the value of participating in demand response and other flexible load technologies and programs, and how we can take those insights to accelerate our product development lifecycle and meet some pretty aggressive flexibility mandates from the state. Again, it's a 2.5-year project. It's about $6 million. We have a pretty aggressive goal of enrolling and engaging 66% of the residential customer base in the test bed. And that level of customer participation is again, it's aggressive. It's well above and beyond averages that you see for other demand response programs throughout the country. And we have a reach goal of achieving 3 to 5 megawatts of flexibility through these activities. So in terms of context for the test bed, we're facing a lot of the same environmental and policy motivations that are happening across the country. The state of Oregon has greenhouse gas reduction goals, 75% below 1990 levels by 2050. The city of Portland has its own goals, as well as a number of our other municipal customers. And in response, PGE has been moving aggressively at our end to transition from fossil fuel-based generation to a greater focus on renewable generation. And with that, obviously, comes a new challenge of the loss of flexibility on the generation side and the need to make that up on the customer side. So finding flexibility in customer loads. In addition to these kind of softer market signals from our customer base and from government, there's a firm signal from the commission itself to say that we have a capacity target that we're actively working towards, that the regulator has outlined for us. And the test bed is actually an element of that mandate from the commission. So there's a lot on this slide. I wanted it for context, and I'll just hit the high points here. But in PGE's 2016 IRP, our Integrated Resources Planning process, we identified a near-term need for capacity. And through the regulatory process and back and forth with the commission and stakeholders, the OPUC set a mandate for us for capacity goals for a summer and a winter capacity goal. We're a dual peaking utility. And in addition to that, they outlined a number of steps that we were to take in terms of understanding the potential for DR in the service territory, and then really coming up with a rigorous, methodical exploration of how we can capture that DR. So they ordered PGE to work with regional stakeholders and form what's known as the Demand Response Review Committee, the DRRC, to help develop and deliver and ensure success of our flexible load program portfolio. And they also directed us with a time certain date to evaluate and establish a test bed where we could experiment with flexibility and demand response programs and deliver those to customers, again, in order to accelerate our product development lifecycle and deliver more capacity in the field to meet that resource need. So the Demand Response Review Committee that we formed is made up of all of the key regional energy stakeholders. And for those of you who aren't familiar, the Pacific Northwest has a pretty robust regional energy landscape for energy efficiency. Obviously, we have BPA in the region, but a number of other organizations that work in the space, market transformation, nonprofits like NIA. We have a number of national labs, and there's a lot of coordination between these entities. So there's a pretty robust group of organizations that we could draw from to bring into the DRC. So we initially gathered the members of the DRC, which were specifically outlined in the commission order, and we did an intensive offsite with them at the Rocky Mountain Institute to talk about the regional needs for flexibility and what they hope to achieve through our testbed work. We iterated through that process and ultimately came up with a smart grid testbed program plan, which the DRC was supportive of and represented our kind of collective interest and goals for this work, which we then submitted to the commission and went through the public process of review and approval. And then after the plan was approved, and to date, we have continued to engage with the DRC on a regular basis. So we meet with them quarterly to give them updates on the plan that we all jointly developed. We present interim findings. We come up with new ideas or kind of lessons learned from the field, and seek consensus and feedback on what we should do for subsequent activities in the testbed. We also bring to them new products as they're being developed. We're launching this week a residential energy storage product, and we took that to the DRC for their review before we went to market with that. So one of the first and most important things that the DRC helped us do was select where we were going to conduct our testbed. So the Smart Grid Testbed program covers 3 different neighborhoods within Portland. These, taken together, these 3 areas represent the customer diversity that we see across our service territory. So there's about 25,000 customers in total. 4,000 of them are commercial. The other 21,000 are residential. And it's about a 70-30 split between single family and multifamily. We also have a lot of diversity of building types spread across these 3 areas. The North Portland area here on the left, which is labeled as Delaware, that's the substation name, is kind of classic Portland 1920s and 30s homes, smaller, more electric end uses, not as much gas infrastructure. Roseway in southern Hillsborough is a newer part of our service territory, and there's a massive new building boom happening there. And there's a lot more gas infrastructure, more air conditioning, larger, newer homes. And then the Island substation, which is located down in Milwaukee and unincorporated Clackamas County, is kind of a mix. There's mobile homes there. There's a mix of home vintages from, early 1900s all the way through new construction built in the last year or so. So our goal in selecting these 3 areas was that as we did these experiments with customers in the field, the lessons learned from our work, if done in a representative sample of customers, would be widely applicable across the service territory, and we could transfer those learnings over directly. So once we selected the areas that we wanted to work, we wanted to get a sense of where customers were in their thinking about and their understanding of demand response and just grid operations generally. So we fielded a survey across the service territory that was representative of our customers, and we oversampled. And you can see the red highlights here on the map. Those are those 3 testbed areas. We oversampled in the testbed, and what we wanted to see was first of all, to get a sense of how customers understood, thought about, and appreciated the challenges of grid operation, but also we wanted to make sure that as we launched the program, that understanding and those perceptions were relatively consistent between these testbed areas and the broader service territory. So we could have a nice, clean reference point for our work. I won't get into too much detail on this slide. You guys can look at it as I talk and maybe later, but we asked a number of questions in the survey. These are kind of the four that really jumped out and measured customer understanding of the grid. And we looked at things like, do customers understand that there's variability during the day on when people use energy, that there's variability during the day on the relative price and the cost of service, and that the utility we have to manage the grid in real time, meeting supply and demand, and that we don't have, contrary to popular belief, we don't really have a lot of ability to store that energy. We have to generate it and dispatch it to meet loads in real time. And we found, again, you can look at it on your own, but we found that generally there was pretty decent appreciation. About half of the customers grasped these concepts. This is a good starting point. And again, the customer understanding of these concepts was consistent between the testbed and the broader service territory. And the reason that we really wanted to start here was that the program theory of change that the DRRC and NPG came up with was about educating customers on their role in managing the grid, and then using our program base to gently introduce them to these the concepts, enroll them in programs, and have them experience peak time events, and when there are constraints on the grid, and having them understand their role in that and experience some financial compensation for helping us manage the grid, and then ultimately moving them over to direct load control or firm resources through technology-specific programs. So on the left side of the slide here, we started with peak time rebates, which is a behavioral demand response program that we run here in the service territory. Of the 21,000 residential customers in the testbed, we received authorization from the commission to auto-enroll customers in this behavioral demand response program. And last July, when we launched the program, when we launched the testbed, we auto-enrolled about 13,500 customers in peak time rebates. And since that time, we do monthly updates of enrollment as new customers move in or new customers become eligible. And we're about 16,000 customers now. So 16,000 of our 21,000, which is about 70% of residential customers, are enrolled in that behavioral demand response program. And that really builds our customer base for the research. So we use that program structure and its delivery to do a number of tests around customer value, which I'll talk about a little bit later. And as customers become familiar with how that program operates and how it influences the grid, we then try and migrate them over to our growing number of direct load control technologies, which includes smart thermostats, which is our largest program. The residential energy storage, which I mentioned a few moments ago, launched this month. Next month, we have a residential electric vehicle charging program that we're launching, and we're doing smaller pilots around heat pump water heaters, heat pump controls, and thermostats, which I'll mention about. I'll reference a little bit later. Not listed on the slide, but also wanted to point out is the 4,000 commercial customers are also included in this program, and we have a small medium business smart thermostat direct load control offer for the small customers, and we have a custom program under the energy partner for our larger customers, where we do an energy audit, walk through, identify loads that are possible in operations, and work with them to enable those loads through new software or hardware update, and then come up with a dispatch strategy that works for their business operations. So this shows how the that actually works.
Hey,
Sorry,
Tim, this is Ed. Your audio quality is degrading a little bit.
Is this any better?
Sounded a little bit better.
All right, so I'm going to go ahead. If there's an issue, I'll switch to my pure audio.
Okay. Yeah, I'll try and monitor it, and I'll let you know. It's hard to tell with just a brief snippet.
Okay. Actually, here, I'll jump over right now.
Okay. Sorry, everybody. It's 2020.
Hey, Ed, can you hear me okay?
Yep, we've got you.
Okay, is that better?
Yeah, it sounds much better. Thank you.
Okay, great. Sorry about that.
Tim, I think the last thing I heard was the direct load control offer for commercial.
Okay, thanks. And sorry about that issue. Yeah, so the direct load control offer for commercial, if you didn't hear that part, so we have a small medium business product that we're offering direct load control thermostats. And we also have a large commercial offer known as Energy Partner, where we do an engineering walkthrough of the site and identify loads that are flexible and the enabling technology they would need, whether software or hardware. Install that on the customer's premise and then work with them to come up with a dispatch strategy that works for their specific business needs. And what we're doing with all of this field work is, it is research, but it's applied research. So the testbed sits on the product development team, and we really try and sit in that space between that 0 to 2 year product development life cycle and our program operations. So we're both field testing enhancements to existing offers, and as we have learnings in the field, we roll them right back into the delivery pipeline. And we're also testing new products and services which are on our longer term roadmap, but we're not ready to go to market with yet. We do some strategic tests around that to look at how the technology performs, customers' perception and willingness to participate in those programs, and some of the technical challenges around communication. And this is really the goal of this work, is to learn in the field, but quickly apply it back to our product work so we can build this resource. And so I mentioned before the customer value propositions and the work that we're doing with our peak time rebate, those 16,000 peak time rebate customers. And what we're doing in this space is really using alternative delivery mechanisms and gamification to tweak the delivery of the program and understand how customers respond. A very traditional kind of transactional setup with a utility and customer is, we want you to do something and here's some money, so you do that for us. Well, we're trying to explore other motivations and see if we can design programs that speak to deeper concerns or considerations from customers. So we've set up campaigns where customers can aggregate with their neighbors and donate their rebates to local nonprofits. We're framing customer participation not just in dollars and kilowatts, but also in avoided emissions. And next summer, we're going to be using some of those water heaters and battery storage projects that we're getting out in the field and dispatching them around renewable generation. So working with customers and framing their participation in the program as enabling our ability to rely more on renewables than fossil-based generation and avoiding peaks. And on the customer demonstration side, I won't get into a great amount of detail on all of these, but we're really testing a number of new technologies that we need to meet our capacity goals. And I mentioned earlier that we're a dual peaking utility. So that includes both heating and cooling technologies. Also water heating, which we see as a large opportunity for us to increase flexibility, as well as some electric vehicle charging work. The one thing I will point out here that we did in the test bed, which is having pretty big impact at the organization, is load disaggregation or asset mapping. So we used our AMI data and a vendor with machine learning and AI technology to analyze our data and help us understand not just what end uses were in the building by type, so heating versus cooling load, but we were looking for the specific type of equipment. So knowing customer has electric heat is great, but what type of electric heat is critical, because that determines the controls and determines our ability to engage with the customer. So we're looking at breaking out a central air source heat pump versus radiant baseboard heating versus a ductless mini split. And so that work happened in the test bed. We piloted it there, and we're now rolling it out service territory wide. Another component of the work that I think will be interesting in the group is we're making a big shift at PGE and better serving environmental justice communities under our diversity, equity, inclusion initiative. And we worked in conjunction with the DRRC to roll this into the program itself. So we have 3 community relation managers, one assigned to each test bed, a neighborhood, and they represent the program and the utility out in the community, and they're engaging with community-based organizations, liaising with the local governments, and really helping us understand from the customer's perspective where our programs fall short. One of the big insights, which should have been obvious but really wasn't until we got out in the field, you know, our kind of the centerpiece of our demand response programs historically has been our smart thermostat program. And the smart thermostat program relies on customer Wi-Fi as the backhaul and communications up to utility dispatch. There's inequity in customer Wi-Fi, and a lot of low-income communities access the internet through their mobile phones. So it's not a stable stationary Wi-Fi source which you would need for smart thermostat program. So those are the type of blind spots which we're using the community relations managers to really get for us from the field and bring back into the product development process. The other thing that we're doing in the test bed that I think is really relevant to the GEB's work is trying to tap into and quantify these additional value streams. I think a lot of demand response nationally, the programs really live and die based on bulk system capacity, and PGE is no different. That's really where our cost effectiveness, that's the cornerstone of our cost effectiveness now. As we move into more sophisticated demand response program designs and other DERs, we understand there's this broader value stack that can be tapped into. So in the test bed, we're doing field work and experiments and building into our evaluation understanding of these value streams so that we can begin to quantify and work with the commission to build out the benefit side of the cost benefit equation in order to have more cost-effective programs and be able to be more aggressive about the products and services we're bringing to market. The last thing that I'll speak to in this is in addition to the test bed, there's a parallel activity happening in Portland General around grid modernization. So we're rolling out our enterprise ADMS system currently to enable distribution automation and Flizzr and a number of distribution services and operational enhancements for the grid. We're also rolling out an enterprise DERMS solution in the coming years. And this this new functionality and visibility from the utility into what's happening in real time on the distribution system is a really critical element to the previous slide, which is realizing those additional values of demand responsive DERs. And so we're in the test bed in this 25,000 customer area. We're testing out some of these new functions. We're rolling out new sensors on these 3 substations and the associated feeders, and really kind of putting some of these hardware and software solutions through their paces, so that when we approach the enterprise DERMS launch in 4 to 5 years time, we'll kind of have worked through some of the kinks and have a better sense of what we can expect in achieving that software rollout.
Tim, if I could interrupt for a second, could you maybe spell out what ADMS and DERMS means for those who may be unfamiliar?
Oh yeah, sorry about that. So ADMS, Advanced Distribution Management System, and DERMS is Distributed Energy Resource Management System. So the ADMS is it's the backbone of the distribution system, of a modern distribution system. So it includes all of the sensors that are deployed downstream of transmission, so we can understand the state of the reclosers, get real-time readings on voltages and frequency, and it gives the utility real-time granular insight into what's happening on the grid. And why that's important for demand response and for DERs comes into play with the DERMS. So the Distributed Energy Resource Management System is the software layer that takes those insights into what's happening on the distribution system and deploys customer-side resources as a solution to grid challenges. So if you have an under voltage situation on a feeder, you can discharge a battery to increase the voltage, for example. So these enhancements and changes that are happening are timed really well with the test bed, because we have a 3 substation, 10 feeder kind of field playground to try some of this stuff out, and to do things at a small scale that the utility is comfortable with, where we would be hesitant to roll it out enterprise-wide because of the potential downsides of that. And this is my last slide. I think as we continue our work in the test bed and start thinking about a potential phase 2 for the test bed, and we integrate our work in with the grid modernization and integrated grid work, this is kind of what we're hoping to achieve. So change the way that we, the utility, think about the value of these customer-owned assets. Traditionally, the utility wants to build, own, and operate all the equipment needed to manage the grid, but that's not the reality moving forward. So it's really a chance for us to change the internal perspective on that, put customer-side resources through the paces, and demonstrate that they can actually deliver predictable value. We want to change the way customers think about that too. So this next bullet is kind of reshaping customer expectations. We want customers to understand and realize that they have a role in the grid and what that role is and how their behavior impacts operation, the environmental profile of our generation, and cost. We want to, as those 2 perspectives change, bring it together into the way that we operate and model the distribution system, and then ultimately start reprioritizing the way we allocate capital to take into consideration coming load growth through electrification, recognizing DER value, and rolling that into our operational capabilities. And that's it for me. There's time for questions.
Thank you, Tim. I'll let Ed handle questions that have been coming in.
So right now we've just got one so far, so get your questions into the queue. So first question is, will PGE's FAN have the capability to replace customer Wi-Fi for individuals who may not have access to smart thermostats or smart EV chargers?
Really great question. One of the demonstration projects we're working on is with a mesh network provider, and we're standing up a utility-owned network in the North Portland neighborhood. And the goal of that work is to test Wi-Fi versus dedicated cellular backhaul with customer-owned mesh or the utility-owned mesh. So we want to stand up those three solutions and look at the uptime and latency and the overall cost in order to inform future program design. We're doing that with our water heater pilot. And I mentioned earlier that we see water heaters as a really great resource for us, and the next one that we're going to dive into. So we're doing the work now on the front end to test different communication paths so that when we're ready to go to market with water heaters, we can understand the relative cost and benefits of each one. I definitely see that as an opportunity in the future. We'll just have to see how it stacks up with cost effectiveness.
All right, thank you. Now, that question was from Hannah, who's the PUC side lead for our Nazio Nehruc working group. So thank you, Hannah. So then we've also got some questions. So how does PGE weigh the relative value of firm versus non-firm resources?
Yeah, I think that gets to the last slide about changing internal perceptions of customer side DERs. You know, utility is an engineering centric organization. Engineers like predictability and control. And if our ability to operate and manage the grid effectively and deliver that reliable, safe, cost-effective electricity is dependent on resources the utility doesn't own, then having it on the firm side of the of the spectrum versus behavioral is kind of meeting the engineers halfway. So having something they can dispatch and measure and see in a more predictable fashion than a less structured and less predictable behavioral-based program is kind of where we come down on that issue.
Thanks. Another audience question. So, Tim, you mentioned modifying cost effectiveness of the test bed going forward and looking at value stack. Can you speak to the types of values you expect to analyze?
Yeah, so in our battery storage pilot, which launches this week, we're going to be looking at residential energy storage's ability to provide frequency, local congestion relief, volt var support, and other values. I think there's really no limit into what we are hoping to see. So I'm really excited about that work specifically.
All right, thanks. So we've got another of our prepared questions. What are the major lessons that the test bed has taught PGE about engaging customers in building a demand-side resource?
I think probably the biggest one from my perspective is having a really clear understanding of what the customer has, and tailoring our engagement to the assets that we're able to control and kind of the value that they're able to provide. Since doing our load disag and asset tagging work, we've really changed the way that we think about DR potential, and we're building more accurate planning estimates around what is technically possible due to how customers cool and heat their homes, how they heat their water in the presence of EVs. So making estimates which are based on their physical assets as opposed to kind of a generic picture of the customer.
All right, and we've got another audience question. How do you envision the pilot feeding into distribution system planning in the future?
Yeah, good question. Our distribution resource planning function sits on the product development team where the test bed sits. So we've been working really closely with those folks and taking the data from the field in terms of customer acceptance and equipment performance, and feeding into their planning models. We're really fortunate that the DRP function is being stood up in the midst of the test bed, so we can kind of tailor our experiments and our field work around their needs.
All right, thank you. So when is the testbed program complete, and where does this work go from here?
Yeah, so it's a 2.5-year program. We launched last July. So our field work is going to end in December of 2021. And we have begun conversations with the Demand Response Review Committee and the Commission around whether or not we'll be able to stand up a phase 2 of the test bed. That process, it's a stakeholder-driven process, and I think the structure and what's included in a potential phase 2 will really be determined by the DRRC members. From my perspective as the program manager, I'd like to see definitely see our work continue, but in terms of where it goes, I want to continue the focus on the customer and move from focusing on how to build the resource to a more clear focus on how to derive additional value streams and how customers perceive those value streams and their willingness to provide those to the utility and what the compensation structure will look like, so that we can maximize customer participation and satisfaction.
Thank you. Another question. So how are you aligning testbed activities with the rest of PGE operations?
Well, we mentioned a few of those already. We're working closely with our integrated grid team and rolling out in the testbed substations and feeders some of the new functionality that they have on their roadmap, and we're working with the DRP team as well to make sure that we're collecting information from the field that is relevant to their new distribution resource planning function. We're trying to position the testbed within PGE as a place where we can work with stakeholders and work with the commission to try things and fail fast and learn. The stated objective of the testbed, is research, and so it's kind of one of those rare instances where we're hand in hand with the commission and stakeholders, and we're allowed to fail, we're encouraged to fail and to try new things, which I think that's my internal sales pitch when I'm talking to my colleagues and other departments, and say, if you have something on your roadmap that's important and big, let's try it here at a smaller scale, see how it works, work with the commission in that process, and then we can scale it.
This is Rodney. Maybe I'll interject a question following on what you were just saying and thinking about the policy context. And this is with respect to the Oregon PUC's order and your development of a DR review committee. We know from some other cases where utilities commissions are somewhat skeptical of pilots. And maybe you could elaborate a little bit on, how the PUC is allowing this, regulatory sandbox and the ability, chance to try things and fail what lessons, might other states derive from this? Was the DR review committee or some other mechanism important for giving the PUC confidence that you all at the utility were working in good faith?
Yeah, I think I think having the DRC as a standing body that guides the implementation of the program and manages its activities, it gives, I don't want to speak for the commission, but my impression is that it gives them some peace of mind. Obviously, they're members of the DRC as well, but having that quarterly meeting where all the stakeholders can get together, and we have the ratepayer advocate as part of the DRC as well. So having a place where we can come talk about our work, brainstorm and collaborate on new ideas, and the commission can see those key stakeholders who would be interveners in any formalized regulatory proceeding. They can see the opinions of the stakeholders and watch them weigh in and watch the collaborative process. I think it probably allays some of the concerns and the need for a more structured regulatory process. And that's allowed us to move more quickly on some of the demonstration work. For example, I mentioned earlier that the commission gave us permission to auto enroll customers in our behavioral demand response program. We went back to the tariff that allowed that, and we sought to change it to give us more flexibility on direct load control. And we went back and forth with the commission on that a little bit, but where they landed was, okay, we're going to let you do more direct load control field research. And instead of doing a formalized tariff for each pilot you want to do, which is the standard process, which is long and onerous regulatory process, they said you write up a research plan, present it to us, present it to the DRC. The DRC is good, and we, the commission, have a chance to review it and approve it. You can move forward. So that I think the goodwill that's been created through the program to date is starting to bear fruit in our ability to move more quickly, learn quickly, and ultimately build that resource and meet our capacity goals.
Great.
A question from the audience. Following up on Rodney's question, how does cost recovery work? Was the testbed approved through a rate case or a separate proceeding?
It has its own deferral budget. So it's like any other pilot program that we do. So we propose our activities, came up with a plan, proposed budget, and we do have a cost effectiveness metric in the testbed, which has an assumed level of customer uptake of the associated programs that we're running. So it has a traditional cost effectiveness metric, and we do our annual reporting through the deferral, and it's treated as part of our larger DR portfolio.
Another question. Does the pilot include any network transmission or distribution system? I ask this question because targeted use of DER for this type of system face more challenges to achieve peak reductions required to alleviate constraints. Puget Sound Energy is having difficulty finding enough DER to defer a proposed transmission project because of the nature of their network transmission system.
Yeah, so our work is primarily focused on the distribution side. I would say the overall resource that PGE is building is, is a bulk capacity load shed, which has some transmission value, but where we're digging in with this project is on distribution side. And I think we're trying to I'm going the opposite direction here. We're going down to local distribution feeder congestion relief, so that the opposite end of the spectrum of value is where we're focused, and then hoping to build back up from there.
I'm going to go ahead and take my moderator's prerogative and ask sort of a different kind of question. How are you in the COVID-19 world doing, you mentioned the engineering walkthroughs for industrial facilities. I imagine there's some sort of inspection if they're, verifying a smart thermostat has been, or other energy efficiency upgrades have been installed. I guess I'm mostly interested in the industrial walkthroughs. Are you doing those remotely? How is that being managed with the need for social distancing?
Yeah, COVID has been a nightmare. As I'm sure everyone on the call, it's challenging for our large CNI is actually the easiest one because you're dealing with other engineering functions within those organizations, and I think those kind of one-on-one or small group like peer-to-peer interactions are more conducive to mask and social distancing and just kind of a professional back and forth. Where we're having more trouble is, we had planned to do door-to-door enrollment for our small medium business smart thermostat program, and just having people out in the neighborhoods walking to businesses obviously is not great right now. Compounded with the challenges that a lot of small businesses have closed, or their energy bill is and participating in programs is the least of their concerns if they are open. So that's been a challenge. Some of our research work has also struggled. We're working with a large customer to do retrofits of all their water heaters with heat pump water heaters as part of that mesh demonstration project, and they have a policy now where they don't enter buildings unless they don't enter occupied buildings unless it's replacing a failed piece of equipment. So our work is, a voluntary change out before end of life, which runs counter to their policy. So, we have COVID field policies that we put in place. We have our own internal process around social distancing and screening of our field staff, but it's been a real challenge for the program.
COVID is a nightmare. It sums it up well.
Yes.
I don't see any other audience questions. Rod, do you have any last questions?
I'm sure after we hang up and log off, I'll have, but not at this point. So thank you very much, Tim, and thank you very much, Casey. This has been a great presentation, and it's really great to learn about your program. We're gonna probably call on you in the future as you get more results and more lessons learned to share with your colleagues at other utilities as well as with our state members. So thank you so much. Ed, do you have any last words or greetings?
Just say thank you for joining us today and for the great presentation, and thanks to the audience for sticking through us and asking some good questions.
Great, thank you all.
Take care.
All right, thanks everybody.